Hello everyone and welcome back to the channel. In today's video, we are going to interface a water sensor with Arduino and display the reading on 20x4 LCD using Proteus Simulation. This project will help you to understand how water detection works using the analog signals and how you can visualize the sensor output directly on the LCDs. Before moving forward, let's understand the working of the water sensor. It has three pins, the VCC, ground, and the analog pin. The sensor detects water through the parallel conductive tracks. As you can see here, these are the parallel conductive tracks. And when water touches the sensor surface, the conductivity increases, resulting in the higher analog value. When there is no water, the resistance is high and the analog output decreases. So in this way, it is the easiest way to detect the presence of the level of the water on its surface. In Proteus, as you can see, we don't have any mechanism to include the water. So there is an additional pin that is called the test pin, and we'll be connecting the potentiometer with this pin, and changing the resistance of that potentiometer will show the change in the sensor's value. Before building the circuit, make sure you have installed all the required libraries. First of all, you have to install this water sensor library. After that, you have to install the Arduino library for the Proteus, and the third one is the LCD library. So let's move towards the Proteus workspace. This is the ready circuit, and as you can see, we have included the sensor here, an Arduino, and the LCD. And the sensor has this pin, test pin. Let me show you by zooming here. This is the test pin, and changing its resistance will change the voltage level at this pin. These voltage values will be provided to the analog pin of the Arduino. The Arduino is the heart of this project, and it will convert the voltage level into the respective analog value of the sensor, and all the results will be shown here on this LCD. So to control this simulation, we have to go to our Arduino IDE and make sure you have included the liquid crystal library to use the LCD in your project. So let's open the Arduino IDE and take a quick look at the code. We begin by including the liquid crystal library. It will control the LCD. The sensor pins are after that. After that, we have defined a sensor pin that is A0. It has to calibrate two values. One for the dry dry state, and the other is the wet state when there is water present around the sensor. So here is the setup function. The setup function displays the introduction of this project. It provides a very professional and interesting way to start your project. After that, there is a while loop. This loop is read by the microcontroller continuously. Inside the loop, the Arduino takes multiple readings from the water sensor and calculate the average for the stable output. The analog reading is then converted into voltage, and the result is displayed on the LCD. The last line of the LCD will show the water condition. So on the LCD, you will see that if the sensor is reading the dry, wet, or the humid condition. So if it is not clear to you at the moment, don't worry. We'll be testing the circuit and all things will be clear to you. To make a connection between this code and our simulation, we have to provide the hex file address created in your system. So what you have to do, you have to simply compile the code. It will provide you multiple pieces of information, including the address of hex file. So you have to copy this. without any quotation marks, as you can see here. Copy this, go to your simulation, double click your Arduino and paste it in the respective place as I have done before, and click OK. So the circuit is ready to test now. Let's play it. And as you can see, this is the introduction of the project as I have mentioned. And at the moment, we are providing the 0% resistance to our potentiometer. So the voltage will be maximum. As you can see here, the voltages are the maximum, and our LCD displays the same result. The value, the voltage, and the condition is wet. So at the moment, the sensor is saying that there is a water around me. So let's change it. The second condition is the humid and okay. Right now, the resistance value is 50%. That is the middle of the resistance. And as you can see, the voltage here also are changed. The values are changed here. The voltage is 2.24 and the condition right now is dry, but we can moving changing the resistance value will change the condition. So it show humid condition, and now on the 100% resistance you can see the voltages are the least. It shows the value is 0, the voltages are the 0, and there is no water around the sensor. So the condition is dry. I hope your project is working fine as mine, and this whole video was helpful for you. If you have any question, you can ask in the comment section.